Right, so what is calculus? Well, calculus is the study of change. So in this video we're going to start with the first area of calculus you'll meet, which is differentiation. So if we consider graph of function y equals f of x, something like this, right? So we're like something like that, say y equals x to the n or something like that. Of course that's not y equals x to the n because it doesn't go for 0, but anyway, we'll just consider a function like so. We know you can't find the gradient of the curve itself because the gradient is always changing because it's not a straight line. So what if you want to find the gradient at a point or a tangent to the curve at that point? Well, let's just draw another diagram here to enlarge it slightly. So I can draw 2 points here. Let's label them P and Q, and we know a line collecting them with a chord which will go through this curve twice. However, we only want the line that goes through it once, and that's only at P. So if we let this point here be equal to x, and this point here is x plus delta x. So if you have a curve here, y equals f of x, well, what are these points going to be equal to? Well, this is going to be f of x, this is going to be f of x plus delta x, right? So what we want is for this line to only cross the graph once. And to only cross the graph once, that means it will only pass through one of the points. So therefore, we have to make this distance between the 2 points x plus delta x minus x, which is just delta x, the distance, tend to 0. So what we're saying is the gradient, which is the change in y over the change in x, or delta y over delta x, and again you could represent this as y plus delta y, or y here as well. So represent this, the limit as delta x tends to 0. But what is this? What is this equivalent to? So what is the change in y here? So the change in y is simply this value minus this value, f of x plus delta x minus f of x, and that's all over the change in x, which is just dx. So there you have it. This is your formula for differentiation, and all it is the measure of a gradient at a single point on the line. Now we're going to try a simple trivial example here of y equals x squared. If you studied anything like C1, you already know what the result of this is, but we're going to prove that result using this formula. So it's the limit as delta x tends to 0 of this. So let me just write that in there a bit more implicitly. There you go. Limit as delta x tends to 0 on the side as well. We refer to the gradient function as dy by dx. So dy by dx is equal to the limit delta x tends to 0 of, so we have f of x plus delta x. So if f of x equals x squared, then you've got x plus delta x all squared. You've got minus f of x, and again minus x squared all over delta x. So here we can simply expand the bracket using binomial theorem. So you get the limit delta x tends to 0 of x squared plus 2x delta x plus delta x squared minus x squared over delta x. Here you can see the x squares cancel on the top. So then you're left with limit as delta x tends to 0 of 2x delta x plus delta x squared over delta x. And look here, right, so you can see there's a common term of delta x in all of these, so we can just cancel that out here. So you've got 2x delta x divided by delta x is just 2x, and delta x squared over delta x is just delta x. Right, so what's the limit as delta x tends to 0 of this? Well, it's just going to be 2x plus 0, which is obviously just 2x. So there you go, the derivative of x squared is just 2x. And there you have it. The first principles of differentiation.